So, this is an experimental talk on an experiment, but it is a fun experiment. We will see how to create an application, helping us in securely reviewing our architecture using the knowledge graph, the knowledge database about cybersecurity of the MITRE. So we'll start saying that a network is a network of vulnerable nodes. Then we need to classify those nodes. And then we will arrive to our application, an open source editor to design secure architecture. We will see that using this experimental application, we can learn cybersecurity concept through assistive functionalities, and we can have a real-time security assessment. Then we will see how this application works under the hood. There are two very interesting parts. But, well, who are you? Well, I am a solution architect at Partech. I am in the Python community from more than 10 years, and it's a very great community. I came here for the code and stayed for the community. I am a Python enthusiast and an API expert. I support the HTTP, IETF HTTP workgroup for writing standards, and I worked for the Italian government digital transformation team. So, our networks, our infrastructures, our platform are networks of vulnerable node. Each node can be expanded or, well, folded, and it has various levels of complexity. We should identify our level of complexity. And every node has its vulnerabilities, and we can be attacked in different ways, dependently of its categorization. For example, a web application server is attacked in different way with respect to a network node with a public IP or a database. So we want to make security assessment. Okay, we should first classify our nodes. But, well, what does it mean to classify network nodes? And this is an example. We have a website here. Our website is connected to the internet, and a denial of service attacks via internet, okay? And a distributed denial of service is a kind of denial of service. But, well, a website is even executed by a server, and the server is a computer. So this is an example of network. There are different kinds of objects that can be targeted by different attacks. For example, I have an iPhone, an Android phone. They are both mobile devices connected to the internet, and malware can attack via the internet. So these are basically the first example of connection. But as we can see, it's not that. It's not all. We can still continue to expand and unfold this kind of information, this kind of graphs, to identify attacks, walk through these attack paths, and identify mitigation. Well, we said before we had network node classes, attacks and mitigation, but we want to use a classification. The MITRE created this DFEND classification so that network nodes are branded as digital artifacts. And they can be targeted by different offensive techniques and defended by defensive techniques. There are other blocks, but those are the main blocks. Digital artifacts attacked by, defended by different offensive and defensive techniques. So this is a more in-depth design of digital artifacts. We can see that we have a user application that is an application, that is a software, that is a digital artifact, and that it has children, developer application, a build tool, compiler, and we have a source code analyzer tool that is a static analysis tool, and so on. We have different mitigation technique, defensive technique, credential hardening, and this shows the complexity that we have to target when we want to have a methodology for defining a secure profile of our application. So defend classifies network nodes, associating to every class of nodes, to every artifact, a series of possible attacks. The digital artifacts can be databases, routers, container image. You can see that we have prefixes, D3F. This means that those are keywords. They are not just words. They are keywords. They are well-defined. They have definition. So imagine we have a postfix mail server. We know that this is a mail service. A mail service delivers email. Email can be attacked by phishing, can be attacked by malware, and ransomware is a malware. This means that a ransomware can attack through our postfix instance. This doesn't mean that the ransomware attacks the postfix, but can attack through postfix. And on the other side, our postfix server is a network server. It can be executed by a server that it can be attacked by theft. Somebody can come in my data center, can steal the server, or can steal server components. Or a network server can be attacked by a denial of service, and so on. We are going to understand that this knowledge graph has a lot of information and can be used in thousands of different ways. So when I found it, I asked myself, what can I do with it? Because it's complex. So we can have thousand million of paths every time I add a network node. I can have thousands possible more connection. So I said, okay, I want to create an experimental PyScript application so that all my colleagues can play with this tool. So, and this application should use Defend to support the secure design of application and platform. Well, challenging, but the first thing I did was saying, okay, how can I describe my infrastructure? Because all the infrastructure were defined, for example, our customer infrastructure are designed on wonderful images, PDF, PNG. Okay, but those kind of images cannot be processed by a computer. So, okay, I need to create meaningful, when I say meaningful or when I say semantic, I mean meaningful, graph representation of my customer infrastructures, not all those images design, and I need a formal language. Well, one source of formal language is infrastructure as code, and I won't speak about this today, but if you browse the Git repository, you can find something like get my Kubernetes manifest file, generate Mermaid graph, generate defend graph from this information, and generate what? But that's not for today. An open source editor. We have open source editor. Do you know Mermaid.js? Please raise your hand. Okay, the ones you don't know, well, I will show you. It's an open source editor. It's in JavaScript, but you can use text and arrows to create diagrams. And you can add labels, text labels to every node. Then this application is very simple. You write your Mermaid diagrams, and in every node, you write D3F dot something. He knows what something is. It can be a database, it can be a volume. He chooses it, makes some magic, but we'll see if we have time, and creates a graph. And then I can query the graph and get the attacks, so the offensive and defensive the associated defensive and offensive techniques. So in this image, we have the diagrams that is rendered, and then, well, we'll see. So I will just say that when I have a client, instead of just client, I say that client is internet network traffic. I annotate this client with this keyword. Our customized mermaid draws a globe. Well, I haven't found a better image, sorry. But this tells that the traffic comes to and fro into the web. And when I say webmail, I tell you that it's a React. The first one, the file React, is just an icon. It's not a defend keyword, but we process it anyway. And the second one is a defend keyword, and we say this is a web server application. And if we want to say that the client sends email to the web application, we just say client, arrow, pipe, defend email, pipe, webmail. This draws this image, but he knows that the client is sending email in some way or email information to the webmail. So the client accesses the email, the client produces email, and webmail uses email. Those are semantic information that can be processed to create a security assessment. Moreover, the editor has an auto-completion feature, so that when I start writing database, in this case is a web app that communicates to MySQL using database something, because I don't know which are the hundreds of categories that are in defend, I can ask to autocomplete. I can see that I have a database, but the web app is not sending databases to MySQL, but is sending database queries. And he explains what is a database server and what is a database query. At this point, he is capable of identifying all the possible threats associated to the transit of database queries, or to each one of those objects. And what do we have? That this PyScript application is capable of generating a list on the right that says, OK, I have a data volume. This data volume is subject to, well, supply chain attacks, sure. But, well, something we might not think about, direct volume access. So I have a database with a volume, but somebody can access directly the information into the data store. So I can read MITRE documentation or the NSA documentation about their volume access, and maybe they can suggest you can encrypt this disk, for example, or if somebody steals the disk, you need some physical measures to avoid this kind of direct volume access. At the disk level, at the, for example, container orchestration level, if the disk is provided by a cloud provider or by a container orchestration. Or another issue, disk content wipe. Sure, I should have a backup, but I can even identify other measures to avoid this content wipe. For example, if I have a specific volume that is read-only, I can say, OK, this is mitigated by a technology that doesn't allow to write to this disk. And which is the knowledge required to get all this information? Well, just this one. Instead of webmail, I have to say that this is a D3F volume, and I get information. So it's very easy to use. For every kind of resource, I can create this kind of assessment. OK, I can get from this information that I can export to a ODF, all the link, the hyperlink to the websites where I can see in detail of the issues that I have from the webmail, or what does it mean a graphical user interface input capture, for example, keylogging, for example, web portal capture. And this information is available to every colleague that has no knowledge about cybersecurity, because you just say you should just test your architecture into this Mermaid editor. So since this information is produced in almost real time, just 20 seconds from the moment you write down the design, you can modify your architecture and your diagram as soon as you're writing it. In this way, you can iterate your design before even writing the documentation code or the architectural document. And you can reuse the snippets from previous architecture, surely. So how does it work? It seems cool. It seems easy. Yes, it's easy. But, well, there is this MITRE vocabularies. There are Python libraries that use this vocabulary. I have the Mermaid.js that works for the graphic stuff. And I have PyScript that is the glue. Well, what's that? On the right, in green and purple, and on the small dots, you have the MITRE graph. And in red, there is the node. In reality, I just write the postfix node in my Mermaid graph. I create a graph, a semantic graph from the Mermaid 1, and then I merge this graph into the larger graph that is made of thousands or 10 of thousands possible paths that is produced by MITRE. The best way to do this kind of analysis is using Neo4j that I used to create this graph, but your colleagues maybe are not interested in it, and I wanted to make it simple. So I picked all this graph into a Python library, and I started creating this kind of reports using Python scripts. Then the team manager of my colleagues told me, okay, nobody will use it because they don't know how to launch all this kind of stuff or set up the Neo4j databases and whatever. And I said, okay, let's do it with PyScript. And it seemed to work. With PyScript, I used this RDF lib. And I imported, this is the URL of the graph, defend mitre.org ontologies defend TTL. TTL is the extension of this kind of graph. I imported the graph, I added mine, and then on G, other than parsing, I can querying. It's very intensive computationally, so you need some, because it's in Python and it's in the browser. So the application structure is this one. There is this index HTML that uses the JavaScript libraries to create a diagram. Oh, this is made with Mermaid. The index HTML uses all these libraries packed in a nice wheel file that generate the inner graph and load the inner graph. They reference the MITRE load databases load in the app. So this is into the inner graph, well. And then generate the reports. And, well, you have even a terminal, but it's not interesting. Thank you. Well, that's it. I hope it's fun. Questions? Or?
Thank you, Roberto.
Oh, well, just one thing.
You still have 5 minutes if you want to show something
okay, else. Because since I have those minutes, I want to risk it all and say that, well, poof, poof, poof. this is, oh, that, no, not this keyword. Oh, it was fast, strangely. This is all Python, mostly. Okay, the build is failing because it's experiment, as I said. But you can use it. You can make pull requests. You can enjoy it. You can browse, and you can use the application that now the hamster is running. And for example, you can have you can design platforms. This is the oops, it's uninitialized. Okay, this is the graph. I mean, the semantic graph that is merged with the other one, and it is queried through PyScript, through Python. Or you can make your own queries here, but it's slower. And you can create hamster running here. Will it work? I don't know. Yes, it works! 38 possible attacks with, well, it's almost one attack per line of diagram. And it's easy. It's a simple diagram. You can zoom it. Oh, well, it associates to every digital. Can you see this? This is a password databases, so something you should play nice. This is an identity server that authenticates the client. There are some other examples. For example, a network. This is a client. Well, what's that? It's internet network traffic, and then a browser that sends requests, HTTP requests, encrypted with TLS to a load balancer. That actually is a reverse proxy server, sure. That has a service mesh with a sidecar container in a Kubernetes cluster. This is a container orchestration software. Well, which is the security surface. Boom, boom, boom. This is the previous one, hamster running, finger crossing. Okay, and this is it. What happens when I port knock here? Wow, it worked. I didn't know it. Well, that's it. Questions?
So the first question that we have on Slido, it's actually something that I think you started answering, which is, can you pair it easily with MITRE ATT&CK? In essence, get correct defense steps based off an entry in the attack framework.
Excuse me?
Can you pair it easily with MITRE ATT&CK, which is the thing that you're showing before this? Yeah, and can you get correct defense steps based off an entry in the attack framework?
Well, you need to analyze the details, because it's not very, it doesn't go at CVS level. But when you use this one, you can, well, the security measures I didn't show you. Okay, you can read the security measure, and you can identify and map this kind of, for example, if you want something practical, you should, you could map this kind of information to an easier technical framework like DevSecOps maturity model that has specific tasks. For example, I need to test my configuration. I need to write down integration testing, unit testing. So usually this is a wide area of knowledge, and you have to filter. You cannot just identify just a simple checklist out of this one, but you can, once that you have implemented those measures with respect to the artifacts, you can put this information in the graph, just like Neo4j, and check which artifacts are defended and which are missing. But you cannot do this just with this simple web application. As I said before, this is made to help people to start using Defend, not for people experienced with Defend. I don't know if I answered the question.
Okay, thank you. And the next question is, did you find an easy way to dynamically generate a network graph in Mermaid.js based off the security infrastructure network, or did that only work in Neo4j?
Well, clearly, it's always an approximation. So you need to, the main part, well, I started knowing the actual graph that I wanted to generate. So I had this one in mind. So while I write down Mermaid.js, I imagined this one. This means that it's easy to generate graphs with Mermaid. You have some problems with the rendering because sometimes to create a faithful graph like this one, you may create a Mermaid graph that is not nice when you see it. For example, you may have stuff moving around or moving in a counterintuitive way. But in general, it's easy, in my opinion, because they are always graph and they are always nodes. So maybe the problem that you have with Mermaid is that what you generate is not visually appealing, but actually it reflects the information flow and the action flow. And probably when we create graphs for our customers, those nice figures, they do not actually reflect the information flows. They are just useful because people that read them has prior knowledge of how information flow. But they can be even misleading because I can make different assumptions of the flows reading a graph. And so I have to read the documentation and ask. While if you use this kind of description, you always map actions as specific keywords. For example, a privileged user that manages a server creates administrative network traffic. Usually this is implicit when you see diagrams, but this is real, and this network traffic can be on the internet or can be in the internet, and they have different profiles. So if you want to do something that is useful for security, probably Mermaid is okay. I think Mermaid is okay. But this is complex stuff. Happy to talk.
Okay, thank you very much. We're just running out of time. So if you have any more questions
thank you
for Roberto,
your interest.
give any interest.